So with your radioactive decay series, each step is going to begin with the nuclide that was in the step before. Okay, just like I've illustrated here. The thorium is going to come down here. So in step 3 then, protactinium will become my starting nuclide. And again, on your assessment, I've explained, or I've given you this series. So I say alpha, beta, beta, alpha, alpha, beta, alpha. So you have the whole list. You're going to start with the neptunium nuclide, and you're going to end up with a stable nuclide. Okay, so that's how you do the radioactive decay series. Now, also on your final or your Unit 6 assessment, you have some half-life problems. And a half-life, which we use the T sub 1/2, is the amount of time it takes for 1/2 of your sample to decay. And again, keep in mind here that when we say decay, it doesn't mean that it goes into nothing. It means that it emits particles and transforms or transmutates into something else. So the half-life is the amount of time it takes for half of your sample to decay. So when you look at the terminology here, or the symbols here, we're going to have M0, which is the mass at the beginning. So this is the mass you start with. And you can see that up here when I copied it, my sub came way down here, but that's M sub 0. M sub T is the mass after some period of time has gone by. Time is that amount of time. How much time has elapsed? And then, of course, the T equals 1/2 is the half-life of that particular substance. Okay, so these are your different terms. So in this example, I have my M sub 0, I have my starting mass, I have the amount of time that has elapsed, 4 half-lives. Doesn't really matter what my half-life is, I just know I have had 4 half-lives. And then I've got I'm looking for the mass after this period of time has elapsed. Now, there are formulas that you can use to work these problems, but they involve logarithms and natural logarithms. And for me, I've found that it's a lot simpler just to make a flowchart. So if I start with 64 grams, after 1 half-life, I'm going to have 32 grams left. Remember, because half-life is the amount of time it takes for half of my sample to decay. So after going through 1 half-life of this particular sample, I have 32 grams left. But I need to get through 4 half-lives. Okay, so after my second half-life, I'm going to have 16 grams. And then I'm going to go through a third half-life, and I have 8 grams. And then I go through a fourth half-life, and I have 4 grams. So my mass that's left is 4 grams. Because I started with 64, and I went through 4 half-lives. 1, 2, 3, 4. And at the end, I have 4 grams of my sample left. Okay, so just draw it out. This would be 1 half-life, this is 2, and write your numbers underneath so you can keep track of that. Okay, let's look at another problem. I have my M sub 0, so the mass I'm starting with is 400 grams, 400.0 grams. The, let's see, let me draw that right. Okay, I have the mass that's left, so they've already told me how much is going to be left. I have my half-life, which is 13.6 days, and I want to know how much time has gone by. So if I have 400, I started with 400, I have 50 left, a half-life is 13.6 days, how long did it take? Okay, so I've got to figure out how long did it take to go from 400 to 50. Well, I'm going to do this the same way that I did that last problem. I start with 400. I go through one half-life, I'm at 200. I go through another half-life, I'm at 100. I go through another half-life, oh, there I am at 50, which is what they told me was my ending mass, or my mass after a certain time. So now I have to figure out how long did it take me to get there, okay? So I'm going to count it up. Here's one half-life. Here's my second half-life. And here's my third half-life. So it took 3 half-lives to get from 400 grams to 50 grams. They told me that a half-life is 13.6 days. So I'm going to say 3 times 13.6 days. And that gives me 40.8 days. So that's going to be my answer, my amount of time. Because after one half-life, after 13.6 days, I had 200 grams left. And then after another 13.6 days, I had 100 grams left. And then after another 13.6 days, I had 50 grams left, which is what they told me I had. So I went through 3 half-lives, each one 13.6 days. So I multiply 3 times 13.6, and that gives me my time that has elapsed. So you're going to have 10 of these. I believe it's 10 or 15 on your Unit 6 assessment, and they're going to be different. Some of them are going to give you the starting mass, the M sub 0, and ask you to find the M sub t, how much is left after a given period of time. Some will be like this, where you're given your starting mass and your ending mass and your half-life, and you've got to figure out how much time has elapsed. You may have one that's similar to this one, where you're given your beginning mass and your mass after the period of time. You're given the amount of time, and then you're asked to figure out, so what is the half-life? Well, in that case, instead of multiplying, you divide, and that will give you your half-life.